Okay, thank you for coming. So today I'm going to show you new Cassandra 3 features. So the content uh, compared to what was announced has changed a little bit. Don't worry, I just add new extra content. I didn't remove anyone. Let me introduce myself. My name is Yuhai Doan. I'm working as an Apache Cassandra evangelist. So my job is to give talks, conferences to help people with Apache Cassandra. So if you have any questions, technical questions about Cassandra, you can ping me with my email or on Twitter. I'm working for DataStax. Who is DataStax? Apache Cassandra belongs to the Apache Foundation. We are a commercial company. We contribute the most to Apache Cassandra, and we provide DataStax Enterprise, which is Cassandra open source plus extra features. So for today's talks, the agenda is first, I will show you new materialized view features. Next, user-defined functions and aggregates. And then the new full-text search index that arrived this week. So very, very new feature. Materialized view. Why did we need materialized view? Well, until now, we used to tell people if you need to query data with Cassandra, you need to denormalize. It means that you need to duplicate your data for your query. For example, I have a user table with the user ID as primary key. So I can only query user by their ID. If I want to be able to query user by their country, I need to I need to duplicate the data into a table which is called user by country. I think we have some issue with the screen, so let's switch back to this one. And yeah, you need to manage manually the user by country table yourself, so it is really painful. Now with materialized view, the idea is you create a view. So this is the syntax, create materialized view, user by country. You can select the columns you want to duplicate in this view from the base table user. And then you can define a new primary key for query. So in fact, what happened in the background is that Cassandra will create this table for you automatically. Okay. And let's see with a demo how it works. So for the demo, I just downloaded some music data from the internet. So I have some albums, some artists, some albums. I load it into Cassandra locally. So let's check. For example, give me the first 100 albums. So here they are. You have the artist name, the title of the album, the country, and so on. And you have also the artist table. For example, give me the first 100 artists. So here you have the ID of the artist, the country of the artist, the gender, the name, musical style for the artist. Sorry, what happened? Here you have, for example, take that. They are rock, pop, and electro artist group. So now let's create a materialized view. I want to be able to query artists by country. So the question is, given a country, list all the artists in this country. So the syntax is that create materialized view if not exist, music artist by country, as select star from music artist. So I want to duplicate all the columns from the base table. And this is the new primary key. So the country is the partition key. And now with this view created, I can try to query my view. For example, give me all artists from the Russian Federation, or since we are in Sweden, okay, here are the artists from Sweden, and so on. So pretty simple. Now, how is it implemented? Every time you update the country from the base table, for example, I want to switch user one country from previous value to FR, which is France. So the update is pushed by the coordinator to 3 replicas in Cassandra. Okay. What happens is each replica will acquire a local lock on the base table, the table user, to be able to read the previous value. What is the previous value for the country for this user? So Cassandra is doing a select locally. And then each replica will create a batch lock with delete from the view where country equals the previous value and insert the new value for the country. Okay? And this batch log will be executed asynchronously and will be pushed to different materialized view replica. Once it has been done, each replica will apply the original update. So set the country to FR, release the lock, and reply to the coordinator. So reply to the client, the update has been done. Okay. So in terms of performance, of course, there are some impacts. When you are writing to a table which has many materialized view, the write is slower. Well, why? Because we have a local read before write. Okay, we need to read the previous value for updating the views. But this cost is only paid once for all views. It doesn't matter if you have 1, 2, 3, 4, 5 materialized view, you only pay the cost once. And also the number of updates depends on the number of views. For example, if I have 2 views, in worst case, I will have 2 views times 2, so 4 extra mutation. 1 for the deleting the old value, and 1 for inserting the new value. But this comparison of write performance is not fair. What we should compare is, we should compare the performance of materialized view compared to the case where we need to do the denormalization manually. And in this case, it is better to use materialized view because there is no client-server network traffic. And it is also easier for the developer because you don't need to take care of the update yourself. Okay. Now, what's about read performance? Usually, people, when they want to query data on Cassandra, they create secondary index, okay, to make it easier to query data. Materialized view is read performance is way better than secondary index because first, when you are reading from a view, you are only hitting a single node in a cluster. Imagine you have a cluster of 100 machines. When you are reading from a view, you are reading from, at maximum, depending on the consistency level, 1, 2, 3 nodes. And the read path is much faster because you are reading the data directly from disk, whereas if you are using secondary index, you need first to read the index and then read the data. Okay. So the idea with materialized view is I am paying the cost of writing more, but then my read path is very fast. Consistency level. When you are writing to a base table, the consistency level is the same, but you should know that you have weaker consistency level guarantees for materialized view. Why? Because if we look back at this update is executed asynchronously. So it means that we do not block until we receive the acknowledgement. We push the update, it is a best effort. Yes, question?
Why do we delete data for all the records that the countries will?
Because if you look at the table here, the country is the primary key of the view table. So if now I change my country from, I don't know, US to FR, I need to remove the old value and to insert the new value. Otherwise, I will have inconsistencies. You see? So yeah, you need to know that since we execute this batch log asynchronously, you don't have strong guarantees that when the update is finished, the view has been updated. Maybe yes, maybe not. And eventually, it will be updated because if the update fails, Cassandra will replay it until it succeeds. Okay. Oh, other question? No. Now let's have a look at user-defined function. The idea is, for example, if you want to compute the sum or an average on a value, until now you need to fetch all the data from Cassandra to the client and then compute the sum average. And if you have a cluster of 1,000 machines, it will be very expensive to have all this data on the network. The idea now is to push the computation directly on the cluster. How to create a function. So this is the syntax, create or replace function if not exist. You give the function name. The signature of the function is quite simple. You have the name of the parameter and the type. The type should be a Cassandra type, okay, not a Java type. Call on null input. What does it mean? It means that you can call this function with null values as parameter. Okay. It means that in the source code you need to check for null values. Otherwise you will have a null pointer exception. Or return null on null input. It means that Cassandra will skip the function execution if one parameter is null. If there is one null parameter, Cassandra will not execute the function and return null directly. So your code is null safe somehow, okay? Return type, so you need to specify the return type of your function. So it should be a Cassandra type, it can be a primitive, a collection, a tuple, or a user-defined type. The language, you can choose in which language you are going to write your function. So by default, you can use Java or JavaScript, Scala, Groovy, JRuby, Jython. You can use them, but you need to put extra jar on the server. So some demo. So here I have some artist, and the artist has, oh, what happened here? The born date, and oh, I have some bugs in my. The artist has a born date and a die date, okay? So user function demo, let's check this one. Not good. Okay. So the idea is, I think I have lost my source code, but the idea is to compute the born date and the die date for the artist. So what I can do is, so now if I'm doing a Java code, so if born is null or born equals empty. Well, if I don't have the born date, I return null. Okay? Else, integer parse. I will parse the born date. Else, if die null, or should be something like this. Equals empty. So if die date is null or empty, it means that the artist is still alive. So we should take the current date. Let's see, return 1, 2, 3 for now. Otherwise, I need to parse the born date. Born year. And then the die year. And then compute the difference. Okay. So let's execute this. Parse for type integer. Parse in, yeah, parse in, exact. Ooh. Okay. So it will fail because of the so let's check. I'm using this function now that I have created. Number format exception, okay, because some of the date is of this format, so you cannot parse. Okay, so I need to do some regular expression. So let's say return just for the sake of the demo. I'm sure that it will work, at least. So you see, for Maria Carey, we return 1, 2, 3 fake value because the die date is null. So we should compute the current year and then subtract from the born date. And for John Lennon, well, we should extract this year, and compute the difference. So I lost my original source code. But you can see that, yeah, with a very simple Java code, you can execute the code directly with Cassandra. So this is for function. Now, in fact, the function is not interesting by itself because this computation you can do it on the client. What is much more interesting is to use function to create aggregates. Okay, for example, group by, sum, average. The syntax of an aggregate is a little bit different. Create or replace aggregate, the name of the aggregate, and then you have only type, no parameters. You need to specify an accumulator function and a state type. What you should know is aggregate in Cassandra is like a for left in Java Stream. Okay, you have a reducer function and you have the state. Optionally, you can give a final. So there is a constraint on the signature of your accumulator function. So the first parameter of your accumulator function should be the state type. And then the remaining type should be the same as the type declared by your aggregate. And the return type of your accumulator function should be also the state type. So this is a reducer function, in fact. Optionally, you can provide also a final function to perform a final step. So some demo, I think this one should work. No, not this one. Yeah. So first, I define my accumulator function. I want to be able to compute all the musical style from an artist, from a list of artists, okay, and count the number of times I see a musical style. So the state is a map. The key of the map is the musical style, rock, pop, and the value is the number of times I have seen this musical style. And then, as an input, I have a list of musical style by artist. So the source code is quite simple. If the style is not null, for each style, if the map contains already this style, I just increment the value. Otherwise, I initiate the counting to 1. And then I reuse this function in my aggregate. Okay, style distribution is the name of my aggregate. It accepts a list of text as input. So you see here this text, and the state type is a map text begin. Init is the initial value for the state. So this is the bracket is the Cassandra literal syntax for empty map. We provide an empty map. So let's just compile it. Finish. Now I'm using my materialized view before. Give me all the style distribution for all artists in United Kingdom. So here we are. We have some unknown style, and then we have drugs in these pops. Okay. Now if I switch to Sweden, for example, what are the musical style distribution? Oh, metal, melodic, pop, rock, unknown, and so on. Okay. So you have here a kind of group by. Okay. A sort of. Not exactly the same group by we have with relational database. Yes.
How easy it is to actually order by number of styles?
Well, there is no ordering because it is a map, not a hash map. See, so it's not ordered by the, you see? It's not ordered by the musical style because D, you have M here and D here, so there is no ordering because it's not a hash map. There is no ordering. In my case. You need to be careful. The execution of aggregates in Cassandra is not distributed. It means that the coordinator will fetch all the value from different replicas to one place and then apply the function. Also, you need to be careful not to use user-defined aggregate on a huge partition or on a whole table, because then you will scan the whole cluster. Okay. And of course, if you are aggregating on a huge amount of data, you need to extend the client-side timeout, of course. Now, some people ask me, should I use Cassandra aggregates, native one, or should I use Spark, Apache Spark for aggregation? I will say, if you are using a single partition aggregation, then use Cassandra native aggregates. If you are using aggregation on multi-partition, it means you want to scan the whole table. Spark is a better choice because the computation is distributed, which is not the case with Cassandra user-defined aggregate. Question? Oh. Last feature. This one is really big. This is a full text search index in Cassandra, native index. So searching with Cassandra has always been a pain point. Okay, you have very limited search predicate, equality, inequalities only, and a limited scope of search, only search on primary key columns. You have also the choice to use secondary index, but the performance was very poor. Why? Because it is a reverse index. It means that it is using Cassandra storage engine for the index structure, which is maybe not the best choice. And also you have a very limited predicate. You can only use equality. If you use inequality with the native secondary index, you will have a full cluster scan. Now, with the new SASE index, we re-implement the storage. So now we use a new index structure, which is suffix 3. If you are interested, look on Wikipedia. Now we have extended predicate. You have equalities, inequalities, and like. The like keyword, as in the relational database. We have full text search engine. It means that you can define tokenizer, stop words, stemming. Okay. We have also a query planner. For example, you have many clauses where first name like and last name like and age between 20 and 30 years old. So the query planner will try to optimize the query path for you, because it knows that by restricting by age, it will have fewer results to filter. And we don't use Apache Lucene. We recorded our own index structure. Who did that? Well, it is a contribution from a team from Apple. Yes, this Apple. And they did it, they developed it for their own usage. And they have been using it in production for 1 year now. So it is quite well tested. So some demo, full text search. So I have my album table, okay? So I do a select count. I have 110,000 albums in my database, so not that big, but not that small either. I want to be able to query on the album title. So I am using a tokenizer because the title is a long text. So the index will split into tokens. It will use stemming, normalized lowercase, so it will be case insensitive. I want also to be able to query on album artist, but this time I don't need tokenizer. So the index will not split into tokens. We'll keep just the artist name. I will want to query on the country, on the album year also. So here, for example, give me all albums where artist name is like ABBA and title like Love. So we all know about ABBA group, okay? Now, if I don't want to restrict myself to ABBA, I can say, okay, give me all artists in Sweden and the title contain love. Okay. So here we are, love, love, love. And they are all in Sweden. All albums released in Sweden, okay. I think there is some, so loves, because I have a full text search here, so everything that contains loves. So loves, lover, lover, you see? Now if I want only love, the exact word love, just remove the percentage. And then I have exactly love and not lovers or loves. Okay? So clearly full text search. And I can also, of course, restrict the year, so maybe between 2009 and 2010. Maybe I will have less results. Okay, only 2 results. Okay, so full text search now available. Really easy. When is it available? Well, this month, tomorrow, official release of Cassandra 3.4. And later, we will support OR-close. It means that the query planner will be able to do like where AA or BB and blah blah or blah blah. Okay, and then index on collection and static columns. So people who are using Apache Cassandra with Elasticsearch, just because they need to search data in Cassandra, now they can use directly the new index and don't need to manage another cluster of search engine anymore. Any question? Thank you.